Last time we looked at systems of equations and how to find the solutions by the graphing method. Today we're going to look at how to solve systems of equations by the substitution method. And then coming up in the next section we'll have another method, and the reason we have more than one method is because sometimes one way is easier, sometimes the other way is easier, depending on how things are set up. So let's start with an example, or two or three, of how this method works, and then I'll come back and explain to you the general procedure, how things are going on in general. So here we have a system of two equations. The first equation is 2y equals x plus 3. The second equation is y equals 2x plus 9. And of course what we're looking for is a way to make both equations true at the same time. What do x and y have to be? What numbers can we put in for x and y to make both equations true? Well, the second equation tells us that y and 2x plus 9 are equal to one another. They represent the same thing. So that means that we can put 2x plus 9 in place of y in that other equation. Whatever it's telling us about y, that same thing should be true about 2x plus 9. So when we make that substitution, we substitute in, okay, 2x plus 9, you go in for y. Y comes out, 2x plus 9 goes in, and the equation looks like 2 times 2x plus 9 equals x plus 3. Aha! So now we have a good old-fashioned equation with just one variable. It's just all about x, so we can work on solving this equation. First, I would get those parentheses out of the way. I would multiply this through. 2 times 2x would be 4x, 2 times 9 would be 18. So 4x plus 18 equals x plus 3. Now I want to get one side for just x terms and the other side for just constant terms by adding or subtracting the same thing on both sides. So here I think I will subtract x on both sides. 4x minus x is 3x. And I will subtract 18 from both sides. The plus 3 over here minus 18 gives me a negative 15. So now I've got 3x equals negative 15. To get from 3x to just x, divide by 3. Undo the multiplication with division. So x equals negative 5. We're done, right? Well, not yet. We have to know both variables, x and y. We're supposed to find out what both of those things have to be to make the two equations true. So we've got a number for x. X is negative 5. Come back up here where it says y is equal to 2 times whatever x is, plus 9. Now we have a specific number in mind for x, negative 5. So if we put negative 5 in for x there, it's going to say that y equals 2 times negative 5 plus 9. That would be negative 10 plus 9, which would be negative 1. So now we do have our solution. We have both numbers, x and y. Put them together, that pair of numbers is the solution to the system. Negative 5, 1. When we write a pair of numbers, we always put the x-coordinate first and then the y-coordinate second. So when you're telling me what your solution is to a system of equations, you have to either write it as a pair of numbers like this, x and y together, with the x first and the y second, or clearly indicate x equals whatever number and y equals whatever number. Okay, let's try another example. X equals y plus 7 and x plus y equals 13. This time the top equation is telling us what x is equal to. It's got x by itself on one side, and then on the other side something that x is equal to. So if x is equal to that other thing, then that other thing can go in place of x in the second equation. So, okay, y plus 7, you're equal to x, you go in for x in that other equation. So in place of x, we now have y plus 7. It's y plus 7 plus y equals 13. Okay, so now this is an equation that only involves the variable y. I've got to solve it to find out what y equals. Okay, combining like terms over here, we got a y plus a 7 plus another y. This y plus this y, 1y plus 1y, would be 2y. So this would be 2y plus 7 equals 13. Then subtract 7 on both sides, and you get 2y equals 6. Then divide both sides by 2, and you get y equals 3. And remember, we need numbers for both variables. Now that we have y equal to 3, come back up here where it says x equals y plus 7, and now we can say x equals 3 plus 7. So x equals 10, and we have our solution. 10, 3 for the x and the y in that order. Now, how about this example? X minus 3y equals 7, and negative 5x plus 2y equals negative 4. Now this time, the way things are set up right now, neither one of these equations has just one of the variables by itself on one side, the way it was in the last two examples. So what we want to do is get it so that that happens. So that one of these equations is telling us either x equals something or y equals something. But we need one of these equations solved for either the x or the y. And it looks to me like the easiest way to do that is to take that top equation, the one that says x minus 3y equals 7, and leave the x where it is, but get rid of the minus 3y by adding plus 3y to both sides. And now it's solved for x. X equals 7 plus 3y. That's not the only way to do it, but that is the easiest way to do it. It would also be okay to solve for y, like leave the negative 3y here and subtract x, and then go from negative 3y to y by dividing both sides by negative 3. When you do that, you're going to get some fractions in your equation, which is not wrong. You can work with fractions. It just makes things more complicated to deal with. So when I'm solving by substitution, I like to look for a variable that doesn't have a coefficient other than 1 or maybe negative 1, because that's going to make that easiest to solve for. I don't have to divide through by anything that might introduce some fractions. So here, when I saw this x without any number out in front of it, I thought, aha, it's going to be easy to solve that equation for x, to get the x all by itself on one side. Now that I have that, I'm ready to make my substitution. X is equal to 7 plus 3y. So I'm going to take that 7 plus 3y and put it in place of the x in that other equation. So what used to be happening to x is now happening to 7 plus 3y. Negative 5 times 7 plus 3y plus 2y equals 4. So now we have an equation that just involves y. We can temporarily forget all about x. Pretend x never existed. This is just all about y. We got to solve this equation to find out what number y is equal to. And my strategy that I like to use for solving equations like this, if there are parentheses, get them out of the way first. So I would use the distributive property to multiply this out. Negative 35 minus 15y plus 2y equals 4. Then the next step I would do is, if there are like terms that are already on the same side of the equation, I would go ahead and combine those. So right now there's 3 terms all on the left side. There's a negative 35, there's a minus 15y, and there's a plus 2y. And the 2y terms I can combine into negative 13y. The negative 15y plus the 2y gives me negative 13y. Now I want the y term to be by itself on one side equal to just a number, just a constant term on the other side. So negative 35, you're not welcome here. This side is only going to be for the y term. So to get rid of the minus 35 that's out there, I'm going to add plus 35 to both sides. Then I get negative 13y equals 39. The 4 plus the 35 gave me 39. And now, to undo this multiplication, right now it's negative 13 times y, I undo the negative 13 times part by dividing by negative 13 on both sides. Negative 13y divided by negative 13 is just y, and 39 divided by negative 13, negative 3. Are we done? Not quite. I said we could temporarily forget all about x, but now that we've found a number for y, now we got to remember, oh, there was also an x involved. I wonder what that is. Well, that's going to be easy to find. Now that we have this number for y, we can come back over here where it says x equals 7 plus 3y. Now that we have a number for y, we can put that in there in place of the y. X equals 7 plus 3 times negative 3. So 3 times negative 3 would be negative 9, and 7 plus negative 9 would be negative 2. Now we are done. We have both of our numbers, so we have the solution. Negative 2, negative 3. So unless I've made some dumb mistake somewhere, both of these equations are going to be true if I put negative 2 for x and negative 3 for y. Negative 2 minus 3 times negative 3, that would be negative 2 plus positive 9, and that does equal 7. And also negative 5 times negative 2, which would be positive 10, plus 2 times negative 3, which would be negative 6, does equal 4. They both work when x is negative 2 and y is negative 3. So now that we've seen some examples of this method in action, let me go back and explain the steps that you go through, how this works, how to do it. Here's the procedure for solving a system of equations by this substitution method. Step 1, solve one of the equations for one of the variables, either x or y, whichever is easiest. Now, sometimes that'll already be done for you, like in the first couple examples, but if it isn't, that's the first thing you have to do. Get one or the other of the equations solved for one or the other of the variables. So it has one variable by itself on one side of the equal sign equal to whatever it's equal to in terms of that other variable. Then substitute into the other equation. So replace the variable you solved for by what it's equal to. Make sure you use the other equation, the one you haven't touched yet, when you're making that substitution. The result of doing that is you will now have an equation involving only one variable, just x or just y. So that equation that's all about x or all about y, go ahead and solve it to find what number that variable should be equal to. Then once you have a number for that variable, take it and plug it back into one of the equations. Could be any one, but it's easiest to use the one that's solved for that other variable. But plug the number you got in and find the value of the other variable. Remember, you're not done until you have two numbers, one for x and one for y. Now, usually this is all going to work out fine, but once in a while, when you make your substitution and you try to solve the resulting equation, all of the variables drop out and you get a contradiction. An equation that just plain is not true, like 1 equals 2. And if that happens, that means that your system has no solution. It's inconsistent. It's the kind where if you drew the graphs of the two equations, they would be parallel lines that don't have any points in common. So you can tell your system of equations has no solution if you get a contradiction when solving. The other thing that could happen is you make your substitution, you try to solve the equation, all the variables drop out, but this time you get something that is just plain true. Like maybe you have 1 equals 1, or 0 equals 0, or 5 equals 5, or something like that, where all the variables are gone and you just have the same number on both sides. That means your system is dependent, which means it has infinitely many solutions. The two equations really represent the same line. So any point along that line, the coordinates work in both equations.